So now in this video, we have a not logic gate integrated circuit right there. There's 6 of them, or hex. We're going to use 2 of them right there. They also have the Schmitt trigger effect. That's important to understand. So it's the 74HC14. We'll come to that later. It's the 7400 series integrated circuit. HC has indication of what transistors are in there, ultimately what its electrical capabilities are versus other versions. And then 14 means that there's 6 of the hex inverters in there. That's basically what it means. So in any case, we'll come to the circuit, and you can see I have the trim pot down towards the negative supply. The logic gates invert what you got. So we have a low input. You expect a high output, except for we inverted it again. So we turn that high output into a high input, and that flipped it to a low output. And we have a blue LED lit up because that's how I wired it. We got positive over there, so the output must be negative or low in order for the blue LED to light up. Whereas if I turn the trim pot high, now this side, this resistor that's limiting current for the LED is to the negative supply. So we know that the output is positive based on the way I wired it up. So we'll kind of zoom in and look at the schematic version of this. So again, let's start with high input right there to one of the NOT gates, and they got the Schmitt trigger effect right there. So A is input, but most schematics you won't see A and Y. Be aware of that. Or this writing, this is all extra too. But we 10,000 ohm trim pot, that's the resistance across the entire component. You got a wiper that slides along there. The inputs don't let current in or out, and so we can go directly to either of the supply voltages. If you got a problem with input letting current in or out or something, you'd have to have like another resistor here, but we don't need that. It's not letting the current go through. So if you have a high input, it's going to flip that to a low output. So the triangle is basically a buffer right there. The voltage that you put in, if it's high enough or low enough, it will output a high or low output for the most part. If it's not a buffer, that transfers the exact same voltage. But digital buffers, high in, high out, but then the little dot, I like to think that's what you think of it like flipping around. So then the high output flips into a low output. And so yeah, we got low. Now that's the low input, again being transferred, but then being flipped to high. And when the output is high, that's like almost 5 volts coming out of it, and the red LED lights up. Usually there's some like voltage loss, especially as you demand more current. We go low, and same thing. Since it's a NOT gate, we'll take the simple route here. It flips to high, and but then we got another NOT gate. Flips it back to low right there. And then it connects to ground as good as it can, and the blue LED lights up. Higher value resistor for the blue LED because it's bright at the same current as a red LED. It's brighter. And so we lower the current by a lot, and then it becomes close to the same brightness. So in any case, low output, there you can see how the blue LED lights up. And then a high, now I need to jump back there. A high output right there. That's when the red LED lights up. So there's the NOT gate. Whatever is in, the out is opposite. And when you flip it again though, then it will come back to whatever you put in will be what you get out, as long as you flip it twice. So there's 6 NOT gates right there. We can output either sink or source 25 milliamps of current for each one right there, and we can work with a range of 2 to 6 volts with this integrated circuit. But if you're using more than 2 of them, so 2 of them, you know, you can get up to 25 milliamps with each of them. That'll be within 50 milliamps of the total current for the integrated circuit. But if you're using like all 6 of them, you gotta take 50 divided by 6, which is, I don't know, like 8, something like 8 milliamps of current each of them. So, you know, probably like stay below 5 milliamps if you're using every single one of them, just to be safe. But just be aware of that. You know, you got to cut down the current if you're using every single one of them. But if you're just using 1 or 2, you can do 25 milliamps of current with each output right there. So, yeah, I think I covered everything on that. You got to power the integrated circuit as well. You always got to do that, even though I didn't show the power pins on there. sometimes you may see the power pins, probably not with logic gates, but sometimes with op amps you do. But whether or not you see the power pins, if you're using the integrated circuit, you always have to power it. And so A is the input, Y is the output. There's 3 on that side, 3 on this side for a total of 6. Usually numbering systems work top, left, down, then you jump across and work your way up. That's what we're showing there, but I don't know, maybe there are other integrated circuits where the lower number will be on top. I'm not sure. I always check the data sheet for the pin layout. And but we come over here, and so there we have an input at the very top. Output, we're not using it. We should not leave the inputs floating. If this was a serious circuit, the outputs you leave floating. If you connect them to supply rail, that's a short circuit if you go to the wrong one. Yeah, you put a supply voltage. You could use a resistor to be safe, or a jumper. But I didn't put them on there because it kind of cluttered the board, and some people may be confused when they see them. When it comes to the circuitry we're using here now, it's probably not influenced by those floating right now. But yeah, there you can see 220 ohm resistor, positive supply. That is the that's the negative supply. That's the short lead, the cathode, long lead, the anode up there, because the long lead, the anode needs to be more positive for the LED to light up. Sorry, I got those polarities wrong earlier. Now we're going to go to a low output. So we got positive there. That's coming to the higher pin. I put the longer pin up on top there. The anode, the shorter pin down right there, the cathode. So that is headed to the negative supply right there for that one to light up right there. So you know the output is low, what we have set here. And here you can see that little jumper where we connect the output of the NOT gate with the trim pot there to the input of the NOT gate down here, where the output heads to the load. So hopefully that all makes sense. I think I covered everything as much as I can for this one. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.